Hey guys, so today we are going to learn Thevenin's theorem and the Thevenin's electric circuit and its formula. These three things are the most important things that you need to know about Thevenin's theorem. And this kind of questions, the questions which is related to this theorem, this diagram and this formula, they would ask for the exam, for BSNL, for JTU, and even for GATE exam, they would ask questions which is related to this. Okay. So here, what the Thevenin says is any combination of batteries and resistance with two terminals can be replaced by a voltage source and a single series resistor. So that means he says that any combination of terminals, two terminals should be there. Terminals are nothing but the points where the circuit ends. Here, positive, it starts from positive and it ends in negative. Okay, so the circuit should have two terminals. That is what they say. And even if they have more than two terminals, it is not an issue. And a resistance. Okay, and there may be several resistors like this, like in this diagram, where two terminals are there. That is plus and minus. Voltage is here. Then resistors are there. Okay, so we can retrieve all these things with VTH and RTH. That is what Thevenin says. And RL is nothing but here in Thevenin's theorem. Generally, they will ask some question like to find the value of I, which is passing through one particular portion. Here they ask us to find the value of I, which is passing through one of this portion. So the unknown current which is passing through the resistor. Okay, this is what RL is all about. So here RL is in this diagram 1 ohm, and other resistors like 6 ohm, 6 ohm, and 4 ohm. This 6 and this 6 ohms are in series, and this is in parallel. The when we calculate by using Thevenin's theorem, we would get a value of 6 ohm, 6 ohm, and 4 ohm. We would get a total value of all these things. That is what RTH is all about. So VTH, RTH, and RL. These are the terms that we need to know in Thevenin's theorem. And to find the unknown current which is passing through this portion, we have to apply the formula, that is I is equal to VTH divided by RTH plus RL. This is what Thevenin's theorem and diagram and the equation is all about. So you have to be thorough with this definition, this diagram, and this formula. You don't need to by heart this theorem. You just need to know the concept. That is what you have to know. Okay, so that when there are some questions related to this, you would be able to answer without any problem. Now you understood what Thevenin's theorem, diagram, and this formula is all about. Now we can check out one problem. Okay, so that you will get a thorough knowledge about Thevenin's theorem. So now we are going to check its application. Its application is nothing but we can find the current which is passing through one portion of the electric circuit. That is the main application of Thevenin's theorem. Okay, so this is a problem that we have now. So if we solve this problem, then you will get a thorough knowledge about Thevenin's theorem. So we can solve this problem. Apply Thevenin's theorem and find current I, which is current I is passing through this portion. So what we have to do is the first step that we need to follow for Thevenin's theorem is nothing but the unknown current which is passing through a particular portion of the circuit. Here it is, this is passing through this. We have to make this as an open circuit. So we have did this. We have opened this circuit, and other two circuits are closed. Okay. So this entire electric circuit we had to draw like this, okay, to solve this problem. And first we had to find out RTH. We had to find three things to find the unknown current which is passing through this electric circuit, which VTH, VTH divided by RTH plus R. First, we are going to find out RTH. To find RTH, what we need to do is we had to eliminate the voltage and current sources from this. So only resistors will be left in the electric circuit. So here you guys can see R ohm is there, R ohm is there. Here 128 ampere, 2 ampere is there, but we are eliminating that and we are eliminating this voltage also. So 6 ohm and 6 ohm. Here 1 ampere is there, but we have eliminated it. So 6 ohm is series to 6 ohm. So that means when resistors are in series, we have to add it. You know that it is a basic concept in resistors. So 6 ohm plus 6 ohm, that is 12 ohm. 12 ohm is actually parallel to 4 ohm. Okay. You can see that it is parallel. So we had to apply a formula which is we are applying for resistors when they are parallel. This is the formula: R1 into R2 divided by R1 plus R2. We have to apply this formula here because 12 ohm and 4 ohm are in parallel. So when we apply this formula, 12 into 4 divided by 12 plus 4, 48 divided by 16. So we will get a value that is 3 ohm. So now we have found RTH, that is 3 ohm. Now you have to find another value, that is RL. In this formula you guys can see that I is equal to VTH divided by RTH plus RL. So to find RL, you may know that the unknown current which is passing through which portion? It is passing through this portion. And when it passes through this portion, it is passing through one resistor, that is 1 ohm resistor. This is what RL is all about. Okay, so RL is equal to 1 ohm. So now we got RTH and R. Now we have to find VTH. To find VTH, what we need to do is the step that we already followed. We had to open the circuit like this. Other things will be there like this. And now you have to apply nodal analysis, okay, to find the value of VTH. Hope you guys know nodal analysis. If you don't know, don't worry. I will tell you how to apply nodal analysis. Okay. So here, like Thevenin says, if we keep one voltage meter over here, we would get a value. Okay, that is the entire circuit's VTH. Okay, so it is coming from this side, right? It is coming from this side. So here is the voltage meter. So here you guys can see the voltage which is coming through. This is V2. So V2 is the overall current which is going to come over here. Okay, and if we start to measure the overall current, overall voltage, we would get VTH, which is the same as V2. So V2 is equal to VTH. Now we have to find this V2 and V1 by applying nodal analysis. When we apply nodal analysis, we have to know one thing, that is I is equal to V1 minus V2 divided by R. This is the formula that we had to apply when we do nodal analysis. Okay, so we have one circuit now. Here you know the value, that is 12 voltage, which is applying through this. And here you don't know the value of this circuit, this point, and this node, you don't know the value of node, and this node also you don't know the value of this node. Okay. So what we need to do is it is in between two resistors. So these two nodes, we have to know the value of these two nodes, so that we can easily find out V2. V2 is equal to VTH. So what we need to do is we have to use this formula. So in this, what we need to do is we have to take this V1 as a node. Okay. V1 has two links here. One is going to this side and one is going to this side, and three links, and one is going from here to here. So we have to take all these three lines which is connected to V1. So first we are taking from here to here. Okay. So here you guys can see that the voltage is coming through this side. So it is coming to V1. So when the voltage is coming to V1, that means we have to apply this formula directly. That is, here V1 is 12, and 12 minus V2 is V1 here. 12 minus V1 divided by the resistor, which is R6 here. So we have to put 6 here. So 12 minus V1 divided by 6. And here, from here to here, from this node to until this end. Here, it is an anti-clockwise. You guys can see that 2A is an anti-clockwise. So that means we have to directly put it as 2A. That is plus 2A. And the next one is from V1, the voltage is passing to V2. So from V1, it is passing to V2. So that means the first one, it is coming to V1. So it is positive. Now, from V1, it is going to V2. So that means it is minus. Minus, we have to put, then in a bracket, V1 minus V2 divided by 6. If 2 ohm is there, then we have to put 2 here. Here it is 6 ohm. So we have to put 6 ohm. 6 is equal to 0. This is the first nodal equation. Now, the LCM of both these are 6. So 12 minus V1 plus V2 divided by 6. And we are taking this 2A into this side. So minus 2A. So here 12 minus V1 is minus 2V1 plus V2 is equal to minus 12. 6 we are taking to this side. So it will multiply. Now this 12, when it goes to this side, it will become minus 12. So minus 12 minus 12. So that is minus 24. So minus 2V1 plus V2 is equal to minus 24. 2V1, so when we multiply that with the negative, 2V1 minus V2 is equal to 24. This is the first equation. And the next equation is nodal 2 we have to find. So it is based on this node, V2. Okay. So here you guys can see that current is coming from V1 to V2. So it is based on V2. Nodal 2 is based on V2. Okay. So current is coming from here to V2, sorry. So that means it is positive. So V1 minus V2 divided by 6. Then from V2, you guys can see there is a, there is a line to this side and there is a line to this side also. But here it is open circuit. So nothing is over here. So that means this is negligible. But here you guys can see it is going to this side. So here nothing over here. There is no voltage over here. So, but the voltage is going from V2 to this side. The current is going from this side to this side. So that means V2 minus, here it is 0. So 0 divided by the resistor, that is 4. So minus V2 minus 0 divided by 4 is equal to 0. This, when we convert this into the equation, as you know, the LCM are 6 and 4. That means we have to multiply 4 with the V1 minus V2 and 6 with this. And we have to multiply this as well. So the answer will be 4V1 minus 4V2 minus 6V2 divided by 6 into 4, that is 24, is equal to 4V1 minus 10V2. We are adding this minus 4V2 minus 6V2, 10V2 divided by 24. When 24 comes to this side, before that we can take 2 out of this. So 2V1 minus 5V2 will come. Divided by, from 24 we can take another 2. So 2 divided by 2. So that means 12 is equal to 0. When 12 goes to this side, it will become 2V1 minus 5V2 is equal to 0. And after, now you got two equations that are nodal 1 and nodal 2. Now you have to apply Cramer's rule to this two equations. First, you have to directly write the equation. Here, you get the x value as 2 and my y value as minus y. And the result is 24. So like that, 2 minus 1, 24. Like that, you had to put here. So 2 minus 1, then here 2 minus 5. You have to put that in a matrix, and V1 and V2 we have to put it over here. V1 and V2 is equal to, these are the results, 24 and 0 we have to put like this. And by applying Cramer's rule, we would get an answer V2 is equal to 6. As I told you before, VT is equal to V2. So VTH is equal to 6V. If you don't know the Cramer's rule, I have already explained about Cramer's rule on basic electricity part 2 in Kirchhoff's law. I have solved one problem by using Cramer's law rule. So if you go through that problem, I have explained in that problem deeply what is Cramer's rule and the conditions that we need to apply for Cramer's rule. So if you go through that problem, you will get an idea how to apply Cramer's rule. So go to that problem so that you will know how to apply Cramer's rule. Okay. So finally, you do this basic electricity part 2. Okay, Kirchhoff's law. In that Cramer's rule I have explained in a problem. So go through that problem so that you will get an idea. Okay. I'm not explaining about Cramer's rule here. Sorry for that. It is all, I have already explained. That's why I am not explaining that here. So please check that video. So VT is equal to 6V, then VTH is equal to 6. So VTH is equal to 6V. Now V2 is equal to 6V, VTH is equal to 6. We got. So we can draw this in a diagram like VTH is equal to 6V, and RTH, that is the overall resistance, that is 3 ohm, and the load resistor is 1 ohm. Now we know how to apply this. I is equal to VTH divided by RTH plus RL. That is VTH is 6 divided by RTH is 3 and RL is 1. So 1 plus 3. So 6 divided by 4 is equal to 1.5 A. So this is the answer. So this is what Thevenins theorem is all about. So now you know the equation, the theorem, the definition and the diagram and the problem from it. This is more than enough to know the concept of Thevenins theorem. So now, I hope that you guys know now what is Thevenins theorem is all about. Thank you for watching this video. If you like this channel, please subscribe. Okay. Thanks a lot.